Next, we'll practice converting between concentration units. This is important because sometimes you will need to make these kinds of conversions as a chemist. What is the molarity of a 6.56% by mass glucose C6H12O6 solution? The density of the solution is 1.03 grams per milliliter. We're given 6.56% glucose solution, density 1.03 grams per milliliter. We need to find the molarity. Well, let's break down the information that we were given into parts that we can make some sense out of. So first of all, we have grams of glucose per grams of solution. We know that if we have a 6.5% by mass glucose solution, then we have 6.56 grams of glucose per 100 grams of solution. So we're going to convert the grams of glucose to moles of glucose using the molecular weight for glucose. Alright, and then we'll convert grams of solution to milliliters of solution using the density, then milliliters to liters, because what we need here is molarity, and molarity is moles per liter. So we have grams of solute per grams of solution, right? So we're going to convert the grams of solute to moles of solute and the grams of solution to liters of solution, and then we'll have the molarity. Alright, so here's how this problem is worked. First, we convert the grams of the solute with the molecular weight to moles of the solute, and we get 0.036412 moles of sucrose. Then we convert 100 grams of solution with the density to, this would be to milliliters, and then we use the 10 to minus third liters is 1 milliliter to convert to liters of solution. Then we put the moles of solute on the top, the liters of solution on the bottom, and we have 0.375 molar glucose solution. Next, we'll get some practice by working the 4 practice and 4 more practice problems associated with 14.5. What is the molarity of a 10.5% by mass glucose solution? The density of the solution is 1.03 grams per milliliter. So we're going to convert grams of solute to moles of solute, and then convert grams of solution to milliliters of solution to liters of solution. So let's go ahead and get started. Alright, so we're starting with, well, let's revisit what 10.5% means. That means we have 10.5 grams of solute per every 100 grams of solution. That's what 10.5% by mass means. So we're starting with 10.5 grams of C6H12O6, and if you look up or calculate the molecular weight for that, you'll get 180.16 grams of C6H12O6 per mole. Right, and that gives us 0.58282 moles of C6H12O6. Alright, next we need to calculate the volume of solution in liters. So we have 100 grams of solution. Alright, and so we're told with this solution the density is 1.03 grams per milliliter, and of course that will vary according to which solution you have. You have to be given that information or be able to look it up. And we know that 1,000 milliliters is 1 liter. And so now we have the value for the denominator, 0.097087 liters of solution. So now we can calculate the molarity. Molarity equals moles per liter, and that's going to be 0.58282 moles divided by 0.0895. No, I got that wrong, sorry. Divided by 0.097087 liters of solution. Alright, that's equal to 0.600 molar. Next, we'll calculate the molality of a 10.5% by mass glucose solution. The density of the solution is 1.03 grams per milliliter. We know that molality is equal to moles of solute per kilogram solvent. Now, we calculated the moles of the solute earlier, and so our numerator is 0.58282 moles of C6H12O6. So now we need to calculate the mass of the solvent. So let me write that down. Mass of solvent, and we're assuming we have an aqueous solution here, so that's water. Alright, and that's going to be equal to, well, we're assuming a 10.5% by mass glucose solution, so we said we had 10.5 grams of the glucose, so that means we had 100 grams of solution. Now we have to subtract the mass of the solute from that, and that was 10.5 grams. So that gives us 89.5 grams of water for our solvent. Okay, well, we just need to convert that to kilograms to get our molality, because we need that in kilograms. 1,000 grams is 1 kilogram, and that's equal to 0.0895 kilograms of water. Okay, now let me move that over so we can see it. Okay, so now we're going to calculate the molality, which is equal to 0.58282 moles of C6H12O6 divided by 0.0895 kilograms of water, which is equal to 0.651 molal.